All right, why don't we get started? Welcome, everyone. I'm Tim Erlin. I'm the VP of Product at Wallarm. And today I'm joined by Stefan Ilian, who's the co-founder of Wallarm. And we're here to talk about the CISO's checklist for securing your APIs and applications, which is an exciting topic. We love talking about this topic, and I think we've got a lot of good content planned for you. So let's get started by taking a quick look at the agenda that we have planned for today. There we go. So we're going to spend a little bit of time talking about the API threat landscape, and security incidents, which are kind of the why are we here of the webinar. And then we'll dive into the maturity model for API security, examine that security checklist that's mentioned in the title, and move from there into talking about next steps, how to get your team ready for API security projects and programs in your organization. And
That's
with
a lot
that,
to cover. Sounds like
it
a
is a
good plan.
lot to cover. Yeah. And Stefan and I will take turns as best we can in presenting the material here, and probably interrupt each other a whole bunch with interesting thoughts along the way.
Yeah, and I'm sorry about that. Sorry.
I'm not
and,
sorry.
and by the way, let's keep it interactive. Whatever questions you have, post it here. If you're listening in Zoom, use Zoom Q&A. If you're in LinkedIn and you're watching LinkedIn Live, post your questions in comments, and we'll be try to answer to the best we can. So
Yeah,
let's keep it interactive.
absolutely. Absolutely. So we're going to start by talking a little bit about the API threat landscape. I think it's probably not a surprise to anyone that this is a growing threat landscape. And in fact, the threat landscape is growing primarily because the API landscape itself is growing. So, sometimes in cybersecurity, we can get trapped in our own little bubble. But we have to remember that cybersecurity exists largely because something else exists with a whole different purpose than being insecure. So we see this growth in the use of APIs because it really has benefited organizations and their ability to deliver applications and services to their customers. 1.7 billion active APIs by 2030 is a prediction from Gartner, if I remember correctly. But I think it's important to recognize that those aren't just the public APIs that you're most familiar with. They're also the partner APIs that you might be consuming or sharing. They're also the private APIs that continue to sort of explode inside the organization, connecting different parts of the organization to each other, providing integration. So it really is, I just love the iceberg analogy because what we see for the most part is the tip of that iceberg. And that growth in the use of APIs is driven by the need for innovation and by the speed of innovation, the increasing speed of innovation, and by the changes in the tech stack that we're seeing. So new technologies come to play, come to bear in organizations. Developers like to play with new technologies as they build new applications. And so it's important that we recognize that those are sort of driving that growth in APIs.
And we
And
definitely
Stefan,
see,
yeah,
yeah, we definitely see how many new protocols are used right now. I think 5 years ago, like WebSockets was kind of like unique thing, like trading companies and maybe some tech companies been using it. So nowadays, like we're seeing much more like GraphQL and gRPC, something that we've never seen before, even 5 years back. So now it's kind of like getting mainstream. One thing to mention, speaking about the evolution of the APIs, is the how many of the APIs every single organization has now. We call it API sprawl, and it seems like nobody can actually answer the very simple question: how many APIs you have? So, do this exercise in your own organization. Go to someone and say, "Hey, do you know how many APIs we have?" And you can make it like almost the
it's
exercise with everybody, and I'm pretty sure nobody will give you an answer. Even if somebody will say, "Hey, maybe like it's 1,000 endpoints," you can ask a follow-up question. How do you know? Because like it's really hard to have a single source of truth. As we see right now, like it's very hard question to answer. And the reason for that is that so many APIs, as Tim said, like some of them external, some of them internal. What makes it worse, some of them are managed, meaning that they are configured and managed by some API management like MuleSoft or Kong API Gateway or some others. But there might be a lot of them that are just, spinned out by the web developers, some virtual machine, and they just exposed and nobody's managing them. There is no governance. So like it makes your attack surface vulnerable to what we call zombie APIs and shadow APIs, and see maybe you can unpack like what are those terms mean.
Sure. Yeah, I would throw. I think three terms are relevant there. You could call the group of them rogue APIs if you like, but there are orphan APIs, shadow APIs, and zombie APIs. And orphan and shadow are the two examples where you have, an API. We're talking about comparing to sort of a specification, right? So what's supposed to be in the environment, and an orphan API is one that you don't see in the environment, but you expect to be there. So it's part of the specification, but it's not actually doing anything. A shadow API is the opposite. It's an API that you see in the environment that people are using, but that doesn't exist in that specification. So that's the shadow. And then the zombie is a change example where it was removed from the specification. So somebody said we should get rid of this API, but nobody actually took it out of the environment, and that's what we would call a zombie API.
It's very important to understand not only how many APIs you have today, but also like what's changing, like what is the state of the things today and like 2 weeks out. So like it's not a static thing you need to worry about. You also need to worry about the changes that are happening.
Mm-hmm.
There is no surprise that with the number of APIs and with the evolution of the tech stack, there is a whole subset of new threats that are only specific, not only important for the APIs. And they're probably a lot of you already aware of the OWASP API security, a great initiative by OWASP by basically breaking down all the API related threats. We do what we call API threat test report. We publish them quarterly. And for that, we analyze all the CVEs, all the bug bounty reports, all the news, all the data about the breaches, and the data that we observe across our customer base to understand like what are the threats are most urgent. And like we publish this kind of like top 10 by ourselves too. So for example, the result of the Q1 report this year was the following. The number one problem was actually injections, followed by the authentication flaws, and then cross-site issues, and then API leaks. And we'll be talking a lot about like all of those threats, but it's important to understand like application center APIs in a way are the very same thing, but it also a different thing in terms of the threats that you're facing. You may have some security solutions in place. You may have some security procedures and experience if you wish to protect some of the applications. But when the more you introduce APIs and new stack, you might be it's important to worry about like are you equipped to face all those new API security challenges and threats. Tim, if you want to add anything here before I move.
Yeah, I would just add that while this list looks a little bit like that OWASP API top 10, if you're familiar with it, this is built off of the data that we've collected from published vulnerabilities from our own platform, and it looks a little bit different because it's really a dynamic list. We adjust it every quarter based on what we're seeing in the environment. And so there are some important differences there from the OWASP API top 10, which is a really valuable tool, but gets updated, every couple of years instead of every quarter.
By the way, the new API threat test report is coming, so we'll be happy to publish it soon. Yeah. No surprise with all those threats, there is a number of API security incidents. It's very easy exercise actually to update all of those things because like every week there is something. So if you follow the news, there is this incident, unfortunately, with a great company, Twilio, where 33 million phone numbers were exposed. So the reason for that is that there was a unauthenticated API, which was basically abused by the attackers to extract all those millions of phone numbers, sorry. So it's a very typical type of security incident for the APIs. We see it all over the place. And it seems like nobody is really protected against that. Just like to piggyback on what we just talked about, the API inventory, you really need to know like what are those APIs, if they are authenticated or not, if they're exposed or not, and it's even knowing the APIs is a very important thing. It's not the only way how the APIs are abused. So like if you see on the slide on the left, there is a now well-known incident with a 23andMe company, which basically there is a bunch of vulnerabilities. I know, Tim, you like to talk about this. Maybe you can comment.
Yeah. Well, there were basically two different attacks chained together here. The first was credential stuffing. So they used stolen credentials. The attackers used stolen credentials to authenticate into accounts at 23andMe. And then they used a scraping technique to pull data from the API using a feature that 23andMe had called DNA relatives. So they would log into, for example, my account, and then they would use my account to scrape the data for all of my quote unquote DNA relatives. And that's how they ended up with 6.9 million users, even though they didn't actually have to take over that many accounts directly. So it's kind of two examples, one of credential stuffing and the other of API abuse, specifically scraping.
Yeah, companies now facing a lot of lawsuits. We'll be talking about credential stuffing down the slides. Um, One of the interesting trend we're observing is the problem with the API leaks. So if we go back for a second to this slide with the threats, you can see that API leaks are the number 4. So we see it all over the place right now because with the APIs, there's a lot of secrets and tokens that are used to authenticate and authorize to the APIs. And unfortunately, it's very common that those tokens and secrets get leaked in a variety of the places like Git repositories or maybe Postman collections. So that was the case with the Mercedes, where the GitHub token was leaked, and it basically resulted in the exposure of the source code. Not a unique example, so that's why it makes it even more interesting.
So, the question that you end up with after looking at the threat landscape is what should you do about it? And certainly there's advice out there about what you should do. We decided that it would be worthwhile to take a collection of sort of the best advice or maybe the most prevalent advice that we could find around how to approach API security and really look at the consensus of what the best practice is. So we looked at the OWASP API top 10. MuleSoft, popular API gateway, they have a set of API security best practices. Forrester and Gartner both provide guidance. And of course, we have our own perspective with the Wallarm API threat stats report. So each of these sources provides a set of controls, fairly detailed information about what you should do. And you can go through all of them and map them together, which is what we did. And we came out with sort of a combined best practice frequency. So this is a categorization to start with. Where do these controls fit in terms of category? And we found that secure design and threat protection were the top 2. So most of the controls fall into those 2 categories. And then you have API discovery, bot protection, and secure testing. I think bot protection is an interesting topic, probably for a whole separate webinar, because bots and APIs are an interesting combination. But that being said, this is that first level of how you categorize these controls. The second level is what's underneath each of those categories. And that's what this looks like. So if you look at secure design, you've got things like building in authentication and authorization, making sure that you have governance, both automated and centralized, looking at encryption, hard-coded secrets, the kinds of things you would expect in secure design. The other big category was threat protection. So if secure design is the shift left approach, threat protection is the shift right approach, which is detecting those attacks and protecting yourself from them. So here you've got things like, the types of attacks you would expect: injection, CSRF, cross-site request forgery, SSRF, cross-site scripting, things like that, as well as behavioral attacks, business logic flaws. Those are the kinds of things you need to deal with in threat protection. And then the other categories have fewer items in them, but that doesn't mean they're less important. They're still valid in terms of best practices. So if you're looking at this list and feeling maybe a little overwhelmed or like you're not sure where to start, that's about what we would expect when looking at that kind of a list. So what we did was we took this and built it into a maturity model so that we could see how you might approach API security depending on where you are in your API journey, if you will. And interestingly, it splits into what we would call developer-driven and security-driven approaches. So earlier in the life cycle or the maturity model, you have more developer-driven activities for API security. When you're first building APIs or first deploying APIs, you've got to focus on getting that data model right, on building in those secure design pieces. Authentication, authorization. We just talked about Twilio, an unauthenticated API. That's a great example of where just making sure that your APIs have authentication and authorization built in is a key component, a key best practice. This is also a great place to start working on API discovery. So making sure that as you build and deploy APIs, that you're actually keeping track of what you have built and deployed. That may be a manual process to start with, but building that in as a practice is important. And then as you grow the number of APIs, you can move more towards some of the secure coding approaches and some of the governance approaches. And this is where you start worrying about threat protection as well. So there are secure design controls that belong in this second level of maturity. The more APIs you deploy, the more likely you are to run into bots. So you have to start worrying about bots. You can start worrying about not just discovering all the APIs, but also understanding whether or not they should be there. A good place to start testing, and as I said, a good place to start looking at the basics of protection. So when I say the basics of protection, I mean basic attacks, the kinds of things that you can detect in a single request. You can see this is a SQL injection in one request. And that's really the developer-driven side of things. You can move then to the security-driven piece. As you mature, you work on protecting against more sophisticated threats, behavioral threats, those kinds of things. You can do more around API discovery and risk assessment. And then finally moving into that advanced security phase, where you're doing things like continuous testing and looking at the really advanced threats and attacks that might come across as well. So that's the maturity model for how you might approach API security as a whole. The other place that we see that I think can be challenging, and there are a couple of questions that are related to this particular slide that have come in, I think, is what are all these tools that exist that do something around APIs? So we wanted to break this down a little bit across these categories. So you've got web application firewalls, WAF. These are kind of the old school tools focused on web applications, not APIs. Most organizations have a WAF somewhere, whether they get it from a third-party provider or they have it deployed themselves, but they're focused on protecting and blocking web applications. WAF has really matured into what we would now call WAP, which is web application and API protection. So that's all the features of WAF plus additional focus on APIs. So here you would get basic API protection. Again, we're talking about stateless single request attacks. You might get some bot management in this space as well. Sometimes it's a separate module, but the WAP tools generally don't do the OWASP API top 10. They generally don't do API discovery and inventory, and they generally don't address business logic flaws. Now, there's also a category of tools called API gateways. And we see customers who are definitely confused about whether or not an API gateway provides security or not. And the answer is both yes and no, because API gateways do provide some security controls. Application and user authentication, access control, some kinds of rate limiting and caching, encryption. These are all features that are applicable to API gateways. But API gateways are not built to do API discovery and inventory, and they're not built to do the threat protection that you get from a dedicated API security tool. And this is where those API security tools come in, right? They're focused on the OWASP API top 10. They're focused on discovering and inventorying and providing a risk assessment for all of your APIs. Often they provide testing. They provide API abuse prevention, focusing on the behavioral attacks, things like that scraping incident that we talked about with 23andMe. And they can also look at API leaks as well, depending on the tool. API security tools definitely don't provide that authentication and access control that you get from an API gateway. So we really are talking about a combination of tools to address that whole maturity model.
Yeah, one way of thinking about that is that you still need API gateways / API management to build secure APIs, because there's no way you would be able to build secure APIs without authentication and authorization and rate limiting. So those are fundamental pieces so that you can develop your APIs in a secure way. But if we're talking about the threat prevention and basically dealing with kind of different threats for the APIs, this is where you need more robust security tooling that will provide threat prevention and abuse prevention and discovery and all those pieces. We have some questions about difference between the web and API, API security products. Maybe Tim, you can explain what's the difference from your point of view.
Yeah. So I think I'm just looking at the questions that have come across. There was one of how does WallArm in particular, which is an API security tool, how does it compare to Okta? Well, Okta is a general purpose single sign-on tool, so they're very different. Okta isn't focused on APIs, and WallArm doesn't do single sign-on authentication authorization. Um, and how does WallArm complement an API gateway? Well, that's what we were just talking about, right? API
Mhm.
gateways are focused on the management of APIs in general, consolidation, some governance in terms of best practices. We're really focused on API security, so discovery of all the APIs, risk assessment, and then detecting and blocking attacks in traffic. Those are the key components for us.
Totally. And we'll be talking a little bit about this in the further slides, but Wall platform includes both web and API security products. So like it's not either or. They both come as a part of the single platform. Let me switch to the next slide and talk about one of the practical parts of this webinar, API security checklist. One of the most popular assets, and one of my favorite assets actually, is what we call API security checklist. You can think about it as a practical guide of how you can secure your APIs. So we really sat down together with internal experts, and we interviewed a lot of our advisors and friends from the product security industry. So to come up with the most important chapters of API security and give you a list of things you need to do basically to protect your, again, different kind of threats. And as you can see on the slide, there are 10 chapters. We start with the improper API asset management, and then comes the API abuse and lack of resource and rate limiting. And the next one is injections. So like there are 10 of them. We're actually doing the new version of the checklist right now, which will include even more. But right now, this is the very practical guide. This consists of these 10 chapters. Obviously, we would not be able to cover all of it during today's webinar. And frankly, this is not even the goal. But I want to give you the insight of how you can think about this checklist and how you can basically, maybe after this webinar, go and talk with the team of how you can protect your internal assets or maybe exposed assets from different kind of threats. So let's start with the improper API asset management and discovery. So we kind of like talked about this a little bit already when we talk about the API sprawl and that people don't really know how many APIs they have. So this is a big issue. If you don't know what to protect, it's really hard to protect those things. Imagine if you have thousands of endpoints, you have hundreds of teams, or at least hundreds of developers, all of them developing their APIs. And, frankly, a lot of those APIs has direct access to the data. They may take some sensitive data as an input. A lot of them will return sensitive data as an output, like phone numbers or maybe PII, PHI data. So it's really hard to know what of those APIs possess risk. And if you don't have tooling in place, if you don't have processes in place, you wouldn't be able to know what's happening. What is the attack surface you have? So these are basically the list of things you can do. Like try to the best you can, like with your engineering team, to make the inventory of all the API infrastructures. By doing so, you will ask hard questions to the people. How many APIs we have? How do we know that we have those APIs? How we learn how those those are APIs even exist? So like you will, drill down, and you will start thinking about the tooling and the processes that you need to put in place. There are some tooling out there that is open source. Like there's this tool Clarity from CISO that can be used in the Kubernetes environment to have a list of the APIs that are managed in this Kubernetes. So you can come up with a robust process that will give you understanding of what is your attack surface from the API standpoint. Maybe Tim, you can add a few things here.
Yeah, I think the point I would make is that API discovery isn't just about how many; it's also about what are they doing? How are they related to your business? You
Exactly.
mentioned sensitive data. So the good follow-on question to how many APIs do you have is which of them transmit and process sensitive data? And if you need to be able to answer those questions because it's relevant to the business, it's relevant to compliance. And if you don't know where your sensitive data is, it makes it very hard to protect.
Moreover, you can do the risk scoring of those APIs. Let's say you have like 1,000 of APIs. It's really, you can't test all of them. You need to prioritize. So like what we see a lot of companies do, they try to create a risk model and say, hey, for example, if this API handles login name and passwords, or maybe SSNs, then it is a high risk API. We need to put a lot of efforts in scanning this thing. So like this can help you to risk score, which is very important. One thing that I didn't mention yet is the gap between what developers and engineering think they have and what is like what actually APIs they have and which of the APIs are consumed. It's very common thing that there is like different versions of the same API. Let's say it's authentication API, V2 and V3, and V3 gets some updates, and like everybody's taking care of this new version of the API. But however, the old version is still exposed for some reason. Like maybe it couldn't be, sunset at some point before, but it's still an issue. It's still exposed, and it's very common that the attackers manage to find these old versions of the APIs. Comparing the specs created by the traffic analysis with what you have with the specs from your engineering can give you a lot of insights about like thinking from the engineering team versus the reality based on the actual usage. Let me move to the next topic here, which is API abuse and lack of resource and rate limiting. When we talked about the fundamental pieces for to develop secure APIs, we mentioned this API gateway. And obviously everybody has API gateway because this is the way you can create the authentication authorization. And rate limiting is one of the most important things, because if you wouldn't have this control in place, your APIs would be easily abused. Even from the load balancer perspective, like you can handle, millions of requests from one single user. You need to rate limit. But rate limit is also a very powerful way how you can prevent different kind of API abuses. So when you have understanding what APIs you have, you definitely should think about the rate limiting, because this is one of the easiest way to abuse APIs. You need to think about like what kind of payloads can be accepted and not accepted, like in terms of the size. A lot of times, unfortunately, we see that API gateways couldn't handle everything here, because attackers are very creative, like rate limit is in a way very simple security control. So they manage to bypass it and still abuse APIs. And that's where you need to think about how you can prevent those different kind of abuse, like scraping or credential stuffing, or some kind of other abuses. And unfortunately, in most cases, if you're dealing with the sophisticated attackers, just using rate limiting in the API gateway wouldn't be sufficient. So you would need to think about security controls and tooling that is more machine learning based, can deal with a more sophisticated attackers. One of the simple things, though, that you can do is to block traffic from the geos you don't need, and you don't have customers. So it might be a good way to block some of the malicious traffic. You can also like block the traffic from the Tor. In many cases, what's helpful is to block the traffic from different kind of data centers, and like luckily AWS and Google Cloud and all the other major providers, they basically give you the subset of IP addresses that you can just block, because it's very unlikely that you are having users from those data centers. But be careful. If you talk about the partner APIs, it's very likely that those API customers would be actually in data centers.
Well, and I think you're touching on the idea that rate limiting and blocking are not they're not all created equal. So if you're thinking about implementing rate limits, you have to also think about how those might apply to different endpoints in the environment and what criteria you might use, what attributes of those endpoints you might want to use in order to implement rate limiting. So that flexibility is really important there as well.
Exactly. Next thing here is injections, and like one of the topics that we like to discuss is that if you look at the OWASP API security, there would be no longer injections as the type of a threat, which we don't like. Let's put it this way, because this is one of the most observed attack we see across the APIs across our customers. And unfortunately, if there is a vulnerability like injection, it's very likely it's a high impactful vulnerability, which causes the data breaches or something of the similar caliber. So you really need to think about how to prevent injections. You need to validate and sanitize all input. I know this is not a new thing, like we've been talking about this since the beginning of the application security, but APIs are no different in a way from the legacy applications. And yes, a lot of frameworks that we're using right now to develop APIs, they provide us like the ways how we can sanitize those things. And a lot of people are surprised and almost amazed, like, why is it even the case with the APIs? Like by definition, you're getting some parameters and they should be sanitized if you're using them from the API. But in reality, we see that a lot of customers, a lot of applications, a lot of open source tooling that are widely adopted, they're still suffering from the different kind of injections. And by injection here, I'm not only talking about like SQL injection, I'm also talking about the SSRFs and others. So you really need to think about all those things. And in many cases, having some security control like a WAP or API security policy enforcement or the better API security product would definitely help you to prevent this kind of incidents. Anything you want to add in here?
Well, there's a really interesting question actually related to rate limiting that was asked, and I want to answer that question before we
Oh
move
yeah,
too
yeah.
far away
Let's
from
do
rate
this.
limiting.
Let's do this.
So the question that was asked was, should rate limiting be used if the application requires subscription? In other words, only subscribed users can use the app. And the answer is absolutely yes, because one of the attack types that's really problematic that we saw in the 23andMe example is an account takeover. So your subscribed users, you like to think of them as known quantities, but taking over those accounts is a common attack. And then once they're taken over, um, undertaking activities that you wouldn't expect from your subscribed users is a common attack method. So in the 23andMe example, you had an account takeover. So now you've got someone who's authenticated as a user who is now scraping the API for that DNA relatives feature, pulling down user data at a rate that a normal subscribed user should never be doing. And that's a great example of where you would want to implement rate limiting for someone who's an authenticated user. So great question. And I definitely wanted to cover it before we move too far away from that topic.
No. It's good that we covered it. Unfortunately, we see this more often than we want to, is that, like you can't really rely on the authenticated versus unauthenticated users, because if the attacker is really sophisticated and motivated, they will find a way to get the credentials to authenticate and to use API. I mean, in some cases, it's more challenging, like especially for the partner APIs, when there is a very limited subset of users. But still, I wouldn't be only hoping that the attacker wouldn't be able to abuse API if it's authenticated. In terms of the injections, just to finish this, one of the recommendations we have, and you can see it as the last item on the list here, is that you can utilize your existing specs, like Open API specs, to validate incoming API requests. And frankly, actually, not only requests, you actually can validate responses too from the APIs. So you can basically take the specs and say, okay, this is the parameter which called name, and it only takes letters. Like it doesn't take, and it shouldn't take any special characters or whatever. So you can do this API spec enforcement to mitigate different kind of attacks. A lot of webs, like in legacy web vendors, are writing this API security specs enforcement right now, which is sometimes can be tricky to use, frankly, because you need to upload the specs, you need to make sure that the specs are up to date. We personally believe this is a helpful feature, but it's also like something that everybody should have. So like that's why we open source what we call API firewall. You can just Google it. I think you can find by just API firewall on GitHub, or you can use WallArm API firewall. And this is the tool we presented last year during the Black Hat conference. We're actually coming this year with a new version of the API firewall that will support GraphQL and will bring a few other exciting things. So if you'll be at the Black Hat this year, come to Black Hat Arsenal and let's talk about this. I think this was the last chapter. Just to reiterate, there are like 7 more chapters in the API security checklist. At the end of the webinar, we'll give you a link. You can download it and like share with the team. I think this is a good practical guide about thinking what are the threats you're facing and like what you can do to deal with them. With that being said, the next chapter is API security training, getting team ready. I mean, like, Tim, what do you think about like overall the training, getting team equipped to deal with the API security challenges?
Well, I think um, e- everybody has to learn at some point in order to be an expert in anything. So your team is probably not an expert in API security. Maybe they're experts in web application security because you were building and deploying web apps. But if they're not up to speed on APIs, now is the time to get started. And it equips them to do a better job of identifying the right controls, how to deploy them. So I think it really is important to consider how ready your team is and how to get them ready for dealing with API security.
Luckily, there's a number of API security trainings now available. I'm pretty sure this is not the up-to-date list, but these are the assets I personally picked, I think, a year ago, and I like them a lot. So there is the free training with the modules on OWASP API from the company or the product called Contra. So you can Google it. We can share the slides too, and you can see all the links from there, which is very helpful because you can have the overview of the threat. You have the almost a playground, a sandbox where you can try out different things in an interactive way. So it's amazing. I would also recommend the API hacking exercises from the guy called Wesley. He's producing a lot of content on YouTube. He was actually a guest speaker of Waller webinars a while back. He's producing a lot of practical content, really API security 101 and API security 202 from the very practical perspective. I highly recommend you to take a look at his videos and also read his articles on the topic. I'm pretty sure there is a number of other helpful assets. Don't be shy, share with us. By the way, we'll include it into the next webinar. The good question here is the theory and knowledge about threats is not enough. The best way to learn something and to understand the attacker and their techniques and tooling would be try to do something by yourself. And obviously, as a part of the product security engineer, you need to deal with the internal pen tests and analysis. On this slide, we wanted to come up with a list of the tooling that can be helpful while testing APIs for different kind of issues. A lot of those tools are open sourced. Quite frankly, when we started to develop this list, the main problem was that most of the security testing products like SASTs were not really ready to test APIs. And in many ways, they are not ready or entirely ready to test APIs nowadays too. For example, one of the challenges with the APIs is that you need to understand the state. It doesn't make sense to test the, let's say, checkout for example, in the case of the e-commerce product, it doesn't make sense to, test checkout API if you haven't added anything into the cart yet with a different APIs. So you really need to understand the sequence of the API calls and how they need to be executed. So that's why testing APIs is challenging. Supporting different kind of API protocols like REST and GraphQL and gRPC is also challenging. So we came up with this list of different kind of tools that you can actually use for the training and for your internal tests. Obviously, OWASP Zap is a very powerful tool. I'm glad that they're developing in terms of the API support now. There's this tool, Wrestler, which is a good concept of how you can implement fuzzers that would understand the state for the APIs. This is a very big deal. There is a version of the Wrestler with a GraphQL support. If you want to, and getting back to this rate limiting and abuse, if you want to battle test your APIs and see how much load it can take, there is a number of tools like AB or JMeter that can help you to load, to generate load for the APIs and test those things. One of the tools we're developing is called GoTestWAF. Maybe Tim, you can talk about GoTestWAF and why it's cool.
Sure. I mean, it's a tool that we originally designed to test WAFs and provide a clear score on what they're able to block and what they miss. both for web application and API attacks, and produces a nice letter grade and a PDF report. And what's really useful there is that it's not really just about whether you've deployed a tool, it's about how you've configured it as well. And I think that's a key component. Yeah.
Yeah, and that's a good tool actually. Even you just getting back to the conversation about what kind of tools can be helpful to deal with the API security threats. A lot of times companies think they have something in place and that their APIs are covered. So this is the tool that can help you understand like if there's anything at all that analyzes the traffic and block malicious requests in the APIs for different kind of protocols. So this can be a good way to understand like where you are right now in terms of the API security for the variety of the API endpoints you have. I want to finish the slide by mentioning Burp. I know obviously Burp is one of the most known tool for manual application security testing. It definitely has a lot of capabilities for manual analysis of APIs too. So it's not open source, but like there's a community version, so you can start with that, especially for the training. Next question, which people always ask, like how I can train, where I can train. And I think I'm actually not, I'm also happy that there's a number of projects that are developing what's called like intentionally vulnerable APIs, like REST API, GraphQL API, that can serve some sort of playground. You can learn the theory about, let's say, Ebola attacks. And then you can go spin up a Docker container with this intentionally vulnerable API, and you can try out different things and see how those APIs can be abused, how you can find those vulnerabilities, how you can exploit those vulnerabilities. It's really, really big thing. And there is this project which is called CrepI from a WASP, this VAPI. Obviously, like a lot of the DEM vulnerable application. So now there is also like DEM vulnerable GraphQL application. Most of those tools you don't need to spend time to spin them up with just like a Docker container. So it's a very easy exercise. It almost can be an interactive workshop for your team. Get your developers in the room, like talk 1 hour about this all WASP API security threats, and then just say, hey, let's go and hack and try, like something, for example, the API. That's amazing.
And pair the testing tools we just talked about with the vulnerable deployments, because that's a great pairing to learn about API security.
Yep, exactly. Good. I think we're good on training. And now one of the most interesting topic for us.
Yeah, so I get to talk a little bit about how WallArm can help, and I know there were a couple of questions about WallArm's capabilities, which I'll do my best to answer through this section. Also, if you have more questions, now is a great time to answer them. We've got just a couple of slides left here to talk about WallArm, and then I'll go through and pick out the questions for us to answer that we haven't answered. So this is a good view of the WallArm platform, just to give you a sense of what the capabilities are at a high level. WallArm is a single platform, an integrated platform. It's effectively a hybrid SaaS, so you can deploy our filtering nodes in order to protect traffic, and then you get a bunch of capabilities that are SaaS based on top of those. We start with our advanced API security, where we provide API discovery, we provide real-time API threat prevention, credential stuffing detection, so really focused on identifying, assessing, and protecting your APIs. We also offer cloud-native web application and API protection, so more of a next-generation WAF or a traditional WAP, depending on how you want to describe that. So that's where we provide protection for web applications and also API protocol support for those stateless attacks I was talking about. So things that can be detected in a single request, a SQL injection, cross-site request forgery, cross-site scripting, SSRF, those kinds of things as well. And across both of those, we're able to implement the kinds of rate limiting that we talked about in order to protect those APIs. And then our attack surface management, API attack surface management, is designed to look outside your organization for API leaks. So that example we gave with the Mercedes-Benz incident, finding a token in a public GitHub repository or a Postman collection, or maybe hard-coded in JavaScript on a web property, and providing you with information about those leaks, giving you the ability to deploy a virtual patch if necessary. Also, just discovering the APIs outside of the traffic that that you know about. So those public exposed APIs that you may have that are unmanaged, that's also part of the API attack surface management capability that we offer. So that's the platform at a high level. Lots of different ways to deploy it, lots of ways to integrate it, but core capabilities there. And if we talk about those core capabilities in terms of what they're aimed at accomplishing, we do think about it in terms of a sequence. We can draw this as a circle, we can draw it as a series of steps, but fundamentally, we want to start with discovery. We want to tell you what you have in your environment. We do this in two ways. First, by analyzing traffic. So you send traffic to us, we'll tell you what we found in it in terms of APIs and endpoints. We also do it with an active scanning component to find those APIs that are outside of your management or outside of your control, but associated with your organization. We move from there to protection. So once you've found the APIs, you want to protect them. So that is processing and analyzing traffic, looking for attacks, both stateless attacks and behavioral attacks, and giving you the ability to respond to those attacks or to block them, which brings us to that response part. So the easiest and first way to talk about response is as that active real-time blocking, but there are other remediation steps that you might want to take. And they're available as well. They might include integration into another tool, alerting into another tool. Obviously, blocking, as I mentioned, is a key one there. And then finally, there's a testing component. So obviously, removing risk is better than leaving it exposed. So identifying risk in your environment with vulnerability scanning, both passive and active, giving you some capabilities to redirect attacks to, from your production environment to a test environment. All of that is aimed at helping you shift left as you protect the environment that you have and the APIs you have as well. And then finally, the goal for us as an organization is really to be a trusted partner. We think that our customers are evidence that we accomplish that, at least most of the time. There's also some evidence in the market from analysts and peer as well. So we really aim to deliver on that trusted partnership, and hopefully we succeed. And with that, I'll take a look for the questions that have come in and see what we've got to answer that we haven't answered. So we've got one question here that's specifically a comparison to Cloudflare. They have features about bots and API Shield. Where do we fit into that sort of ecosystem? Cloudflare is an interesting one because, of course, Cloudflare is really their core business is as a CDN. So they're not security first, but they have a security angle. And they're generally deployed on the edge. That's really where they exist. WallArm's deployment is much more flexible, so we can offer protection in more ways than Cloudflare can. We can protect more of that API traffic, and we're 100% focused on API security. So we really do a better job of diving into the details. We catch more of the attacks. We decode the actual requests if they're encoded, and so there's and we have broader protocol support as well. So generally speaking, Cloudflare is a good idea as a sort of an edge tool. WallArm is a little bit more comprehensive when it comes to APIs as well.
It's not uncommon, by the way, when the company and the customer is using Cloudflare, for example, for DDoS protection.
Yeah.
And they still use API security tooling like WallArm to discover APIs, provide the protection against the WASP API top 10, and test APIs for different kinds of security issues.
Yeah. We've got a question here. How are you supporting homegrown APIs? So from our perspective, if you mean a developed API or an API that you've developed in-house, that's kind of the core target for what we're protecting in most cases. While there's evidence in the market that you should be worried about all of the APIs in your environment, including the ones that you get from off-the-shelf tools you've purchased. The reality is that the companies that are most focused on API security are the ones who are building and deploying APIs. So those homegrown APIs are certainly the majority of what we protect today, I would say, just based on what the reasons that the customers purchase.
There are a lot of questions about the recording and the slides. We definitely will share the recording and the slides with everybody after the webinar. No need for the screenshots, as they say. There is a question about protection of SOAP service. But basically, we're committed to support pretty much every API protocol. at least like a standard API protocol. So like if we talk about SOAP, we definitely protect everything XML based, in addition to REST and gRPC and
Yeah,
GraphQL and the other protocols.
yeah, yeah. There's another question here. How do you accomplish the scan for API discovery? So I think maybe I answered this, but I'm happy to answer it again. There are two ways that we do API discovery. One of them is by analyzing traffic. So you send traffic through what we call our filtering nodes. We analyze that traffic. We discover all the APIs and endpoints in the traffic. We also pull out the headers and parameters that are in use. We identify sensitive data. That's really the more comprehensive discovery component that we have. We also have the API attack surface management component that I mentioned, which is focused on discovering publicly available APIs. And that is an active scanning technique. So you give us a domain, we enumerate all the subdomains that we can find, and then we go out and we actively test all of those subdomains for APIs that we can find. And when we report back on whether or not we found any, and also on whatever tools are protecting them. And then we actually use that Go Test WAF tool that we've developed to provide you with an assessment of how effective those controls are.
We will continue answering the questions. I just want to show this link and QR code for those who are asking about the API security checklist. You can download it from wallalarm.com, but if you want, you can just use this QR code to get a link. This is the easiest way to download the asset.
Yeah, good.
The question, what's your market, enterprise, mid-market, small businesses?
Generally speaking, APIs are a horizontal challenge. So API security applies across most of those organizations. Obviously, teams and companies that are developing and deploying APIs tend to be the most invested in API security. I would suggest that that's not dependent on business size. You have small startups where their entire business is dependent on APIs, and you have large enterprises where most of their business is dependent on APIs as well. So it's really the importance of the APIs to that organization that drives who our customers are.
Yeah, there is one question I think interesting one do you have an automated governance model for the API lifecycle? And the person who's asking the question said he developed one, and he's been implemented in a few large banks. So the question is, do you have an automated governance model for the API lifecycle?
Yeah, so in terms of governance, I'm not sure what's meant there by a governance model. In terms of governance, we do you can upload API specifications and compare them, both for enforcement but also for governance to determine if the APIs in the environment match the specification and if their usage matches that specification. I'm not sure if that answers the question. Governance can be a bit of a sticky word. So
governance is a lot of things. I'm pretty sure about that. Like we definitely can help to have the API lifecycle governance here, because we can. There's a lot of that where we contribute, starting with the API discovery, understanding like if what do we see in the traffic actually mention the specs. So like there's a lot to unpack here, as Tim is saying, but happy to discuss this.
Another a couple of questions here. Yeah, go ahead. Sorry, you go ahead, Stepan.
Yeah, go ahead.
So there are a couple of questions here about cloud deployments for APIs. So, if an API is in AWS or Azure, do we integrate, and where can I find the API traffic in the AWS cloud? So the short answer is yes. There are lots of course, companies that are building and deploying APIs in AWS and Azure and GCP. And we have deployment models for our filtering nodes, as I called them, that allow you to deploy in those clouds in multiple ways, actually, in order to capture that traffic, in order to have it flow through those nodes. Where you deploy them and how you capture that traffic is dependent a little bit on your application. So the best thing to do would actually be go to our documentation, docs.wallalarm.com, and look at the deployment guides for the one that best matches your situation. And of course, you might have multiple types of deployment depending on how your organization builds and deploys APIs.
There's a question related to the API security testing. How does Wallalarm integrate with CI/CD pipelines to ensure security is a part of development lifecycle? So we provide a Docker container that you can make a part and one of the steps in CI/CD pipeline. And this Docker container takes a few parameters to launch so that it can perform the testing. So this testing will be happening locally within your infrastructure as a part of a CI/CD pipeline. I think what's interesting to add here is that you can actually utilize the inventory from the API security, API discovery. So we can discover all those APIs, and you can use the specs to test those APIs, which might be handy in a few cases.
And
Yeah.
that is an interesting example of integrating. Yeah, CI/CD pipeline might be a stretch there, depending on how people are actually managing their specifications. But you can actually point WallArm to a URL for those specs, and if you keep those specs up to date as part of your development process, then WallArm will always have an up-to-date copy of the specification and always be comparing that specification to the traffic you actually see in the environment.
Do you have more
All right.
questions that we haven't answered?
I think we've answered all the questions that have been posed so far.
I must say, we have a great audience today. Thanks for
Yeah,
asking a lot of questions. It's always a pleasure to keep it interactive.
I agree. I agree. So with that, there's one last question. Always one last
Okay.
one that jumps in. How does WallArm integrate with APIs running on Kubernetes? That's a great question. There is a deployment option, multiple deployment options for Kubernetes, but the most common or the most popular with Kubernetes is just to run WallArm as an ingress controller. So that's a great way to do it. You can just capture all the traffic that way. But there are a couple other options. So
Yeah,
docs.wallarm.com is a great place to look for those choices.
some companies would use sidecar option, especially if they want to protect internal microservices, that are not necessarily exposed. So it's pretty common to use sidecar too.
Yep.
So that it,
It is.
as Tim said, there is a multiple options to integrate into Kubernetes. We like Kubernetes a lot.
We do. We do. Okay, great. With that, thanks everyone for joining us. Really appreciate the time. It's always fun for Stepan and I to present this kind of material, and hopefully it's interesting and useful for you as well.
Thank you, Tim. Thank you all.